Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 7E. This is number 9, and it says answer the following question using arrangements with repetition, permutations, or combinations. And they want to know how many anagrams, that's where you rearrange the letters, of the letters beautiful can you make. So there are 7 letters here. And we have a B, an O, a D, an E, an F, a U, and an L. And they want to know how many different 7-letter words can we make with these 7 letters. And we're going to be using the multiplication property for probability here. And what that says is that if I look at how many ways I can place the first letter, and then I look at how many ways I can place the second letter after the first letter's been placed, and so on and so forth until we get to the end, and we take all those values and multiply those together. That's going to give us the total number of combinations of these 7 letters. So let's take a look at that. So we have 7 places here. 1, 2, 3, 4, 5, 6, 7. All right, so for this first value, or the first letter, there's 7 different possibilities. I can have a B, an O, a D, an E, an F, a U, or an L. So I'm going to write 7 here. There's 7 possibilities for the first one. Now for the second letter, I've already used one of the letters in the first one because this is without replacement, which means it's dependent. So how many combinations are there now for the second letter? Well, there's only 6 left, right? Because we chose one for the first, so there's 6 left. And then for the third space here, we're going to have 5 left. For the fourth space, we're going to have 4 left. For the fifth space, we're going to have 3 left. For the sixth space, we're going to have 2 left. And for the last space, there's only going to be 1 letter left that we can do. So this is a way to figure out the total number of combinations, and then we simply just multiply all these together, and that's going to be the total number of combinations. And let's see what that comes. Now I could write that all out, 7 times 6 times 5 times 4, but times 3 times 2 times 1, but I'm going to do it a little bit easier because I noticed that this is actually a factorial. This is equal to 7 factorial. And if you put an exclamation behind a number, that means that you multiply that number by the number that's 1 less, by the number that's 1 less than that, and so on and so forth until you get down to 1. So this is exactly, by definition, 7 factorial. And instead of writing all that out in my calculator, I can just do 7. And if I hit the math button and go over to probabilities, you see the exclamation point. That means factorial, and that's multiplying 7 times 6 times 5 times 4 times 3 times 2 times 1. So that means there is 5,040 different possible combinations. 5,040. All right. Now let's talk a little bit about if you could use the same letter more than once. So for example, what if we said how many different ways are there to arrange with these 7 letters, and you can use any of those letters as many times as you want. So it could be all F's, it could be all D's, it could be all O's, it could be all L's. And in that way, what we're going to do is, well, then we have 7 possibilities for the first. And since we can use that same letter again, we're going to have 7 different combinations for the second, and then ... all the way until we get to the last digit there. So this is going to be 7 times 7, and there's going to be 7 of those. So that's actually going to be quite a few more combinations, and we can find that out by doing 7 raised to the 7th power. And that's 823,000 different ways. So imagine how many more ways there are if you can repeat each one of those letters. All right, guys. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.